I think I'm set up. I think we're recording. Can you guys see the screen? You can't see the screen. Sharing screen, right? You can see me? Hello?
Yeah, we can see it.
Okay, good. All right. You have a final exam next week. Did you say you wanted it on Friday or you want it on Thursday? I can't look. School sets the day on Thursday, but it's a remote class. It shouldn't interfere with any of your other classes. You still have the option to take it, excuse me, on Thursday if I extend it to Friday. So I might just do that Thursday, Friday. Any objections to that? Shouldn't be a problem for anybody. Okay. So lost my share for some reason. Okay. What's going on here? Why have I lost my share? Huh. All right. I don't know what's going on. Okay. So let's take a look at what else. So you have this you have today's the 5th, nothing's due. On the 10th, everything is due. And then the 12th is the final exam. It says the 12th, but it's not the 12th. It's going to be the 13th. Okay. You have a project due this Saturday. Any questions on that so far? Any specific questions? I'm not going over it again. You should do it. You get one question. Somebody asked, how do you want to present this 5-minute video? Is the writer or the speaker? Just the speaker is fine. Okay. All I want to hear in that video is how smart you sound. That's it. And that you're telling me something interesting, relevant, and informative. I'm going to check, if I want to check your numbers and everything, I'm going to check them right on your worksheet. So that's what I'm looking for. All right. All right. Anything else? Well, now let's talk about last time we didn't, what did we review last time? I feel like didn't finish something.
The muscle stuff before the midterm.
Right, midterm stuff. I know I went over all the questions. I know I went over all the quizzes, all of the quiz stuff, yes? Up to the midterm. Shall we look at this quiz stuff after the midterm? Let's finish that off. Did we look at the midterm itself or no? No, I'll look at it later. Let's go through all the, let's go through 8, 9, and 10. 8. That's how I was doing it in your class. What does sigma notation do? Anyone? Shupavi? Sigma notation? Sigma notation. Is it as of anything to do with definite and indefinite integrals? No. Definite or indefinite, definite integral or infinite rectangles? That sounds like finding the area exactly. When the graph is below the x-axis, that's negative area. Area and antiderivatives. That's what the fundamental theorem of calculus does. It relates area and antiderivative. Remember, you take an integral And you evaluate it, you take the antiderivative and evaluate it at the upper limit and the lower limit, you subtract them, and that gives you the area. Okay. Add up heights and multiply by widths. That sounds like a way that summation finds areas by adding up heights and multiply by widths. That's adding up rectangles, heights and widths. What's this last one here? Add terms. How about that one? What do you think? Suhavi, are you there?
Yeah, I'm here.
Do you think add terms is the answer?
Yeah.
Yes, you'll use sigma notation in a lot of classes, including especially like statistics. Oh, and speak of the devil, there's sigma notation. Who wants to say this? Jacob, you want to say this? Jacob? Hello? What's,
Yeah, sorry, hold on. I'm not sure.
just say it. Say it out loud. Okay, that sigma is sum.
The sum of 100 when n equals 1, n squared equals 100 times 101.
You don't have to say anymore. It's not said that way. It's not read from top to bottom, it's read from bottom to top, but the sigma comes first. So you say the sum as n goes from 1 to 100 of n squared equals all that. So if you look at these choices, you'll see that they all start with the sum from n equals 1 to 100. All of them say that, except for none of these. So remember, you won't have multiple choices on the test. You'll have to say, and then the function is n squared. So if the function equals, okay, and then that big number is probably one of these. It's probably 338, 350. Yeah, it's definitely that last one. The sum from n equals 1 to 100 of n squared is, okay. All right, next one. Okay, so we have these. Let's go through all of them. We'll start with Sarah. Sarah,
Yeah.
can you tell me what's happening there? On line 2. So there's just one line here.
Sigma notation.
It is sigma notation, but it's adding up a bunch of numbers. What type of numbers is it adding up? What does 2n minus 1 make for numbers?
It gives you 215.
No. 1 to 215 is just adding up 215 terms. But these terms are special terms. When you see something like 2n minus 1, 2n, if you take 2 times some number, it's going to be an even number, right? So if you take 2n and you subtract 1 from it, what happens when you take 1 from an even number? What do you get?
An odd number.
And that's what it is. This is the first 215 odd numbers. Okay. All right, next one. You. What's that say?
Let's say,
Oh, he's going to answer it. Go ahead. Yeah, sure. Go ahead.
The sum of,
Or you don't have to read it. Just tell, of course, first one is to add up a bunch of things. But the second one says the exact same thing, only it's equal to that. Do you know what that
the
is?
sum of, n between, 1 and 47, 46. Times n squared
It's not times, it's of n squared.
of n squared equals, 33,511.
Right, but it's also equal to this right here. Because why? That's the whole thing you're going to have to figure out when it asks you. That's what? That's a formula. That's a summation formula for n squared. Okay, that 46, if you do you see where there's ever 46, if you change those 46s to, if I want this, if I want, here, look, if I want 99, all I have to do is change all these 46s to 99s. Because it's a, you see the difference? One is a summation thing. I'm asking Desmos to do something you couldn't possibly do. But here, I'm asking something you could definitely do. You could multiply 2 times 99, add 1, multiply it by 100, multiply it by 99, divided by 6, and get that exact same number. There's a formula. So this is one of the summation formulas. So you don't have to use Desmos. Okay, next one, 7 and 8.
It's the area one, right?
It's either an area or a sum of values. So they're just adding up a bunch of functions. So it's adding up a bunch of heights, or it's adding up a bunch of heights times widths. What do you think? Nah, it's just heights. There's no, if it was multiplied by that number, 0.125, that's the width.
Oh,
That's changing by, it's just adding up a bunch of values. And that's why it's that number. If you see, if I did something like the integral from, oh my gosh, 0 to 1, f1 of x dx, I wouldn't get a number anywhere near that. The difference is I have to multiply this number by times 0.125, then I get a number near. It's only 5 rectangles, it's not a great approximation. Okay. All right. 11, 10 and 11. You want to take a shot at this one, Davon?
the same one.
It's the same thing, just adding a bunch of things. Okay, Melanie, how about this one? Okay. So let's dissect this first. The stuff in here is all the same, so it doesn't matter. This is not what's changing. These are all the same. What's changing is the original problem is going from 3 to 7. Now it's saying 3 to 7 is equal to 1 to 7 minus 1 to 2. So what did it do? Any clue? It would help to see the choices, but this one is just basically you're starting at 3 and you're changing it so it starts at 1 so that you can use the formulas. The formulas, that formula up here only worked because we started at 1. So if you're starting at 3, you have to break it up from, you can start at 1, go all the way from 1 to 7 and then subtract 1 to 2. Okay? I don't think will we do that in real life. Do this all the time in real life. You don't, let's say you have it's just you want to go from the midpoint to the end. But you have a way, you have all the information from the beginning to the midpoint and the beginning to the end. So all you do is you take the beginning and the end and you subtract the beginning to the midpoint, and then you get, that's how you get the answer. No, I'm sure I'm going to do this with my retirement, figure out how much money I'm supposed to get, because they give you the year totals and then they give you the total to a certain point. So then you can figure, if you want to know what it is after that, you can subtract. All right. Okay, Melanie, now you can see what happens here. Now that they're giving you this, but what have they done? What have they done here? What do these look a lot like? They look like that, don't they? So what did I say that was? Those were just the summation formula. That's it for all those pieces. So it's just from summation formulas. This is the same thing as the other one. It's just this is the summation formulas. This is not summation. This is breaking up the summation. This is using the formulas. Okay? So there are two different steps. One step is to break up the summation so you can use the formulas. One is taking that step and using the formulas. Right, let's see if there's any others. Okay, Melanie, one last try, because I haven't heard you say anything. This one right here, 1 to 67. These are all 1 to 67. So what did they do? They didn't they didn't break it up a different one way, they broke it up a different way. Haven't done any summation formulas. There's no formulas in there. It's just the summation is broken up. This is technically properties of summation. Okay, how about here? Here's some properties, and now what did they do with that first line? Actually, both of them are just what? Summation formulas.
What's the 22
Which one? 22?
or the one above?
This one?
Yeah.
This is just properties of summations. You could say summation formulas too, but I think it's properties of summation. You can break a summation up, like you could break up an integral, but you're not using any of those summation formulas. Here, you're using the formula. If you're adding up 367 times, that's 3 times 67. I don't know what the multiple choice is. That's just a property of summations. Break them up. All right, now here, what are we doing here? Let's see who's online that hasn't answered in a while. I'm not scared of it. There were more people there before it went on. Okay, Suhavi, I'm back to you. There's only 3 people. 3 people home, 3 people there, 2 people missing. Not a good idea to miss the classes of the review. Whatever. No problem. Okay. What are they doing here? They're adding up. Is this an area or is it a? Are we adding up a bunch of values or are we adding up rectangles to get an area? What do you think? This is an area. What?
I think rectangles, I'm not sure.
This is the one where you're adding up for area.
Okay.
This is an area one. And what is this? What's the definite integral? Definite integral gives you what? Indefinite integrals tell you the antiderivative. What do definite integrals tell you? What is this going to tell me? There is no h of x here, so let me just throw an h of x in. Okay. What am I doing when I do that? What is that answer 1/3 equal to? Okay. Come on, you guys need to know what a definite integral is. It's one of those fundamental things I asked you that you need to answer quickly.
Is it like area of like a curve under a curve?
Area under a curve. Yep, that's correct. So, do you see the little purple thing there? That's the area under the curve, and that's equal to 1/3. That's what this thing says. That area is 1/3. There's the function, there's the area, that's the area. But the first line, this is adding up how many rectangles? 800,000 rectangles. And you see how close it is? It's really pretty close. 1, 2, 3, 4, 5, 6. It's 7. It's 6 decimal places are the same. Okay. So this is really close. So what we're trying to do is find the exact area. Okay. 800,000 rectangles is like the exact area. It's really close. But this is that's the exact area. Any questions on that? How about this one? 2829. What are we doing here? Is this an area thing or is it a Adding up a bunch of values thing. It's an area thing. This one, area or adding up a bunch of values? Area. This one, area thing or adding up a bunch of values? Area.
Can you go back to the adding up?
One that just adds up?
Yeah.
It doesn't have here's one that just adds up. It doesn't, see, that's the incremental difference that gets multiplied by the end, and it's not there. It's only there once. If I put it in here, then I'm adding up areas. That's an area. What is it the area of? This I'm just doing on the fly. It's integral from something to something. I know what the function is. I know the function. The limits are hard to figure out. Where's this adding up? What's the first rectangle it's starting with? What's the first, where's that first rectangle starting? What value? When you plug 0 in, what do you get to the function? When I plug 0 in for n, in here, what do I get? No.
Oh,
1.16. Okay, and what's the last thing it's adding up? When I plug 16 in for n, what's 0.2 times 16? That's 32, that's what? 3.2? So that would be 4.36. Oops, I don't know where I typed that. Oh, I typed it in the wrong spot. So they're close, but they're not that close. Okay. Nyla was there. Okay. I see Suhave's here. Thank you, Suhave, for coming. Oh, Anusha's new. Thank you, Anusha, for showing up. But there was a Nyla, remember?
yeah.
Honest, did you know what she looks like? Oh, Nyla, of course. Why did she go? Who do I not know in this class? So Nyla was here last time. She was sitting right there. How do you know? Did you see from the
Yeah,
classroom? I know you were at home, but you look at the classroom when you're at home.
well, we can see the board for 5 minutes, so that's all I can see is the classroom.
Oh, because I didn't come in and share the screen. I'm just curious. But I don't even know what shows up on the video sometimes, because if I share the screen, sometimes my face shows up in the videos, which is annoying.
Yeah.
Sometimes it doesn't. Maybe I don't think it has. There's a setting in Zoom for that, but I don't check it every day. So sometimes it's, all right, let's move on to the next question. All right. Sum a bunch of values. Uh-oh. Sum a bunch of values. I'm going to use Desmos to sum a bunch of values. So I have to create a function. I already have an x, so I'll just use m of x. M of x equals x squared. It's 2. And then I have to add them up. So sum. How many am I adding up? So I'll start with 1. And I'll go to 40 because that's how many I'm adding up. And it's just the function, which is m of x, m of 0.1 times n. That should work. Why isn't it working? Oh, it's another m already here. Here we go. So the answer is 301.4. So I just put the function in. I say I'm adding up. How did I get 1 to 40? Well, look, this is 0.1. There's 1/10. Then it's 2/10. Then it's 3/10. So I know the incremental difference is a 10th. I know I'm going 1/10 there's 40 tenths. So I'm going to end up, if I put 40 in there, I'll get 40 times 0.1 is 4. If I put 1 in there, I get 0.1. Everything works out. It's all good.
It'd be the same if you did 0.
If I did, so here's the thing. No, if I did 0 to 39, I'd get a different number. So look at 39. I get a different number. But then all I have to do is add 0.1 here, and then I get the same number. Okay, because when I plug 0 in, I'll get 0.1 times 0, 0 plus 0.1, that's 0.1. When I plug in 39, I get 39 times 0.1 is 3.9 plus 0.1 is 4. So I could start at 100 and go to 139. I just have to change these numbers inside to make sure that they're being evaluated at the same spot. Okay, answered the last one. All right. Okay, Desmos worksheet, small study. Use the integral to find the number of cases from week 0 to week 20. This is the one it's already in there. There's the answer. How sad is that? They want a whole number, 7314. I think I should be able to copy that to account. Even too lazy to type it in. No, I missed one of them. I missed this one because I didn't say it, but this was the sum of values evaluated at various points. We didn't.
So there's no multiple choice, so I remember all of them.
What do you mean? I'll remember all of what?
So for question 3, the like definition, what's going on?
What's going on?
Yeah. Like, the different-
There might be multiple choice, but there might be multiple choice. I don't remember. Or 3 is technically a writing problem. I don't grade it by you saying stuff. So you have to write your answers in a box or whatever. But if I don't recall that it's a box. I don't recall that. So I suspect it's multiple choices. I suspect. What?
Just show number 4 again. How you kind of do that?
How I add it. I put the function in. My function is M1. And I'm adding up M1s, but I'm evaluating the first number I have to evaluate is 0.1. So the first number I'm going to put in here is 0. So I put 0 in for n. This becomes 0 plus 0.1 is 0.1, right? The last number is 39. Okay, when I plug 39 in there, 39 times 0.1 is 3.9. Plus 0.1 is 4.0, and that's where I wanted to end, was 4.0. Okay, I wanted to start here and change by 0.1 and end there. Now, I did this really fast. I could have spent more time on it. I could have looked at the incremental difference. What's the difference between 0.1 and 0.2? That's 0.1. So that's going to be what's multiplied by the n, because that's how much we needed to change by each time.
Okay, so what's in front of the M is just adding the 2, right?
What's
the
in,
difference
right,
between
that's the
the first-
incremental difference right there. I think usually I write it this way. When I've been doing it in the past, I've been writing it this way, where I put the 0.1 in front. I put the starting value, that's the starting value, 0.1, boom. Then I have to add an incremental difference times every n. So first I find the starting value is 0.1. Then I see the incremental difference is 0.1. And then I multiply it by n. And then I have to figure out how many of these things am I going to use and where do I start? If I have to start at 0, so the first term doesn't add any incremental differences. And then I have to figure out what the last number is. So that this whole term turns out to be 4.0, because that's the last number. So you could just solve that if you wanted to. In fact, I wish I showed you how to do it that way. I think I showed you a box. We just sit there and hit enter and then it count. But honestly, best thing to do is probably just say 0.1. Probably just solve that. 0.1 plus 0.1x equals 4. And then you can look at the, you can find the answer. There's the answer right there, 39. Okay. See how I graphed the line at x equals 39. There you go. Any questions on this? You're good? Let's move on to quiz. So as far as the questions on the exam goes, there's surely one or two of these vocabulary. You know there's going to be a summation, and you're going to have to say it. You get better at saying it. There's going to be at least one of these. Not sure if it's this particular one, but might be. And then you're going to have to do a calculation, either adding up values. So the thing about adding up values is I prefer the one where you add up, you find the area. Adding up a bunch of values, I don't prefer, but I'm not saying it's not on there. But it could be.
So.
That's Riemann sum is the one we're finding the area. That's what they
That's
call
the
it.
area. And
It's
then
approximate area is Riemann sum.
that area under the curve.
The exact area under the curve, that's the definite integral. Or Riemann sum with an infinite number of rectangles. I never showed you that. It was on, there's a lecture on it, but it was just it was going to make you all crazy. Literally, you take the sum of rectangles, the Riemann sum of rectangles, and then Melanie, you use those formulas. When you use those formulas, you can take the limit as the number of rectangles goes to infinity. And then when you do that, the fundamental theorem of calculus pops out. And then you get the answer. But you can do it. It's just a whole lot of, just watch a YouTube video. It's better. If you ever want to see it, watch somebody who's good at it do it. It's not really, for me, it's a waste of time to just sit there and fall asleep. Because I can't put it on test. It's just some of those things for you to say, oh, that's how this all comes together. Why is he covering Riemann sums and then definite integrals? We have definite integrals, but we didn't have definite integrals at the beginning of time. So the Riemann sums were how, look, most people approximate stuff in life with rectangles. You know, if you have a room and it's got a funny curve to it, mostly you're just like, well, this is some area, that's some area. You use some bunch of rectangles. But this Riemann sum thing is a specific thing so that you can do all these vertical rectangles so that you can make more and more of them so you can get the exact answer. But you could, I really hope and pray that if you're painting the room in your house and you're using gold paint or something and you have a funny shape, that you will take a picture of the funny shape, that you'll plot the points in Desmos and create a curve and have it just use this definite integral and say the integral from here to there, what's the area of that thing? And then you can get the exact area, how much gold you need to paint your room, that weird shape. I hope you'll think to do that. In Calc 2, so I'm going to tell you Calc 2 story. What I used to do to seduce people to stay in the Calc 2, because it's a really hard course. I mean, not hard course, it's just one of the first things we do is we find the volume. We use the area to find the volume. So we take so what we do is we have these things, we would revolve them around something like, you can imagine a bundt cake. Do you know what a bundt cake is? It's got a hole in the center and it has this shape. So I'd slice the bundt cake and I would take a picture of it and I would show them a picture of the bundt cake. And then they would take a ruler and measure. They could measure the bundt cake, actually. I think that's what they did. I brought in rulers. And they measured the bundt cake and they created a curve out of the bundt cake, put it into the calculator, used a definite integral to find the area of that parabola of the bundt cake. And then you can use the properties of Calc 2 to figure out what the volume is. a very cool thing to do in life. Let me tell you what I hate about Calc 2. Seems really interesting in the beginning. The first like 4 classes are really good, just enough time for you not to drop. And then it turns sour really fast. It doesn't turn sour, it's not bad. It's just it changes from look at how cool Calc 2 is to look at how awful Calc 2 is. But you're already, once you're in there, you're thinking it's gonna be a great class. Sucker. No, it's not a bad class. Anyone taking Calc 2? Who are you taking it with?
I have no idea.
There's 2 professors, Rose or Anderson. Yep, some people like him. He doesn't allow a calculator. Rose does, I think, but he doesn't like it. They're both kind of old school teachers.
You
Oh.
can't teach Calc 2.
I'm retiring. I'm leaving. I take the pressure. I can and I have taught Calc 2 lots of times. All right, next question. This one. All right, can we go on to the next module? That was 8. How you doing, Sarah? Still here? Oh, did Sarah just leave? Just like she said she'd leave at 4:30. And she did. Okay. 9 integrals. Let's take the quiz. Remember, you can take the quiz as many times as you like. The quiz is good preparation for the test. What are the 2 types of integrals? Definite and indefinite. When the graph is below. So we actually had all these, didn't we, before, sort of? Interesting. Say this. Jacob, you want to say this? Oh, I haven't. Can you say that?
The
Otherwise,
integral,
go ahead, Jacob.
the integral from 0 to x, f prime of t, dt equals f of x plus c.
That's correct, but it's none of these here. The integral from 0 of the derivative of the function is the sum of the integral. What? No, that's not it.
So now,
The integral of the derivative. Okay, the integral from 0 to x of the derivative of the given function of t is the sum. No, that's not it. The top one. Derivative of the integral from 0 to x of the given function of t equals the sum of the derivatives. No.
it's the 4th, right?
Integral from 0 to the derivative of the given function of t is the function of t plus a constant. Yes, that's it. Okay. All right, all of these. Let's look at the choices. Geometry to find the area. Average value. Fundamental theorem of calculus. Integral properties. Area of the shaded region. The position function given the velocity or acceleration. Okay, you take a picture of those so you remember
Yeah, so
that.
Wait.
Okay, so let's go in. I felt like I was giving the categories in Jeopardy. Okay. Can I have properties of integrals for 50, Jack? Okay. What are they doing here? Okay, Melanie, I'm picking on you again because look, this is the integral from 0 to 6, right? And now they're saying it's the integral from 0 to 1 plus the integral from 1 to 6. Seems like integral properties. Oh, that's not the one we have. Do you see that that's just one of like the summation of summation properties?
Yeah.
That's all it is. And it's breaking up the same way. If you want the area between here and that door, you could do the area between here and the chair and then add it from the chair to the door. It's just, that's all it is. The property of integrals that you can do that. Okay, next one. Oh, no. It's all of that. What do those capital F's mean? Capital F's mean antiderivatives. If this is a definite integral, these are definite integrals. This is an indefinite integral, and we're subtracting indefinite integrals. What was the thing that was so important to calculus that it related the two of these? Definite and indefinite integrals. Do you remember? It was so important. Which of these things here connects? You know how the mean value theorem connected average rate of change and derivatives and instantaneous rate of change? There was a theorem also that took the area under the curve, the definite integral, and turned it into the subtraction of the antiderivative evaluated at the upper limit and the lower limit. I know I said it here just this class earlier tonight. I said it for this afternoon. The fundamental theorem, I kept giving you hints. It's so important. It's fundamental. It's this close to saying fundamental. Okay, that's what it does. It's a theorem of calculus that relates them. That's what this did.
So it's a mean value theorem.
The mean value theorem is the one that connects. Look, whenever we have this or that sort of things, there's usually something that connects them. The thing that connected average rate of change and instantaneous rate of change was the fundamental theorem. This theorem connects the definite integral with the indefinite integral. And it's the fundamental theorem, but it's also
So we see the antiderivative.
antiderivative is a big hint. Okay, 8 and 9, moving on. You see there, I have a function and now I have this formula. What does that formula do to the function? I think that's the one we have to answer to. 8 or 9. What is that formula? What does it look like? Okay. Doesn't look like it, but remember I told you the thing that related. Let me just, yeah, it's that one. No, wait. If you use the fundamental theorem of calculus, it's going to be the antiderivative evaluated at 6 minus the antiderivative evaluated at 2. What does that look like to you? That looks like the average rate of change, right? Remember I told you something with integrals that looked like the average rate of change, but was not the average rate of change, is the average what? This is the average value. Wasn't that one of these choices here? Find the average value. That's the answer for this one.
So
Okay, it means the area divided by the length is the average value. The area divided by the length will give you a height. If you have an area that's a rectangle, just imagine it's a rectangle. You have that area and you know the length, and you divide it by the length, you'll get the height. But if the function's going up and down like this, the height that you get is the average value. What, between the antiderivative and the derivative?
between just those two. Yeah. Making sure I got it.
I mean, if I wanted to get numbers for this, which I can, hold on. Capital H of X equals, what's the antiderivative of this? X cubed divided by 3 minus 2x. Okay, so now I have both little h and capital H. Now I can do this. If I cut that, it gives me an answer 15.2. That's the average value. What's this? That had better be the same number. And it is. That's the fundamental theorem of calculus that says this thing here is equal to that thing there. But this formula itself is the average value.
Oh,
Okay, if I just want the area of the underneath that curve between 2 and 6 is 61. But when I divide it by 4, I'm getting the average height. Remember this? Do you remember this? Look, let me just grab this fun. There's the function right there. Okay. Want this function only between 2 and 6. Okay, that's the area. Okay, now let me put the y equals 15.333. That's the average value. Okay, so in other words, it looks, it's hard to tell. It looks a little what to you?
It's like the top half is small.
But it is. It totally is. It's that top half only has to fill in. This only has to fill in this area right here, which is not as big as it looks. Oh man, I'm so drunken. Look at that. I'm not drunk. I can't drunk. See that? This area here, you go to that area there. You can't really see. Well, let me draw. Hold on. This up to get rid of my terrible drawing here. Let me just put in the line x equals, what is that, 2? See that? And then x equals 6. See a little better. That piece there has to go into that spot there. And then it would be a rectangle and it would have that height of whatever it is. That's the average value. This is the average value, 15.33333. Okay. Cool. All right, let's do some more of these. What's this? This is really not great because it doesn't follow the first line. The second line has nothing to do with the first line, but they're both examples of the same thing. What are the examples of? I'm taking this as a definite integral. What's a definite integral? What's a definite integral, Anusha? What does it tell you? What does a definite integral tell you always?
I'm not completely sure.
What? Not completely sure. Of course you're completely sure. It tells you the area under a curve, yes?
Oh
So-
yeah, sorry, I
So
forgot.
how are they going from an area under the curve to just this 8 times 5 is 40? How are they getting the area that quickly? Is there something here about finding the area? Were they using the fundamental theorem of calculus? Saw no antiderivatives. Any other areas? Did they find the area of a shaded region? They used geometry to find the area. How? Because the function they're talking about is 8. That's just the y equals 8. And between 1 and 6 is just 5. So it's a height of 8 and a width of 5. 8 times 5 is 40.
How they go from that to
That's a triangle. 3x looks like a line going like this, right? So between 0 and 1, it's 1/2 the base times the height. The height is 3. The base is 1. And then there's 1/2. That's a triangle.
so are they both just examples of it using geometry? There's no correlation.
There's nothing between the two of them.
Oh.
That's what I was saying. There's nothing between them. In this particular problem, there was a rectangle and a triangle. But this was just them using geometry to find it. Yeah, sorry about that. Okay. How about this one? I see the capital F's. Fundamental theorem. Fundamental theorem. How about this one? Why did they put an absolute value in there? I know that's the area under a curve. Why would they put the absolute value in? They want the area between -1 and 2, but by putting the absolute value in, they're actually, it's a different function. If I put an absolute value in here, take a look at that function and tell me what happens when I put the absolute value in. Come on.
So it turns
So
positive.
you see, everything's positive because I want the area of the shaded region. So in this particular homework problem, they wanted the area of a shaded region. The area of a shaded region must be positive, and that's why they can't. The graph itself was going below the x-axis, and so it was having a negative area. But no, we said no.
Is that the only way we know? Area of shaded region, there's absolute values.
Yeah, because area of a shaded region is the whole point. When you did those homework problems, there were pictures, and the shade region was shaded, and they said find the area of the shaded region. And I went over this. I said you can't just use the area. You can't use the integral. The integral will, when the function goes below the x-axis, it's negative, and then you get negative area. So the only way you can get rid of that is you could do them separately and turn the one positive, or you can put that absolute value in there that does the same thing. I know it's tricky. What's this? Capital F's. Fundamental theorem. Oh, capital H's, but what? This isn't just capital H's, this is something else. Capital H of X, I see a fundamental theorem here, but what is this for? What are they doing with it? Average value.
Yes.
It looks like the average rate of change, but it's the average value. Okay, how about this one? Melanie, how about this one? What's going on here? I'm picking on you because you had the same problem. Just tell me what it is. Not average, that looks like this. There's an integral from -1 to 2, and now what is it? What's happening to it? It's being what? Broken up using properties of integrals. Yep. You see that? -1 to 0, 0 to 1, 1 to 2.
So that's the integral properties, the one above, like before the equal sign, before the fundamental theorem.
Which one?
That right there.
This one?
No. That
Oh.
one. Yeah.
So this is the antiderivative. Not the function, but the antiderivative.
Right.
But what they did was they said, if I took the function itself and I went here to here to here, then I could just subtract the antiderivative. They're taking the antiderivative and finding the average value from it. For this, the average value of the original function, not the antiderivative.
So that first half is the average value.
This is the average value.
It's a fun-
That's the
That's-
fundamental theorem. So this actually has fundamental theorem and average value, but I would say it's average value. Because they started with this and they're ending with the average value. The answer here is the average value. Okay, if I take this out, oops, if I take that out, it would just give me the, oh no, don't go away. It'll just give me the average value. It'll just tell me what it is. Watch, if I take this out, that's the average value, 15.222. Okay, all that is saying you're going from this step to that bunch of steps. What you're doing from the first step to the second step is finding the average value. This is just using the fundamental theorem of calculus to do it. Okay, if it looked like this, if it was from that step to that step, then that would just be the fundamental theorem, because you're starting with the average value equation and you're saying, how did this change? Well, it changed because there's the fundamental theorem. Okay, this is properties. All right, what's this? No? What do S and D mean? Those are special notations. This is special.
S and D.
S
Oh, I see.
and V. What does V mean? And S means position. So you're starting with, you know, the position that position is equal to that, and then you're actually finding it. So what does it say? That's the choice, finding. Find the position function given the velocity of acceleration. So they're giving you the velocity function. Between there and there, they're giving you the velocity function, and you're finding the position. Okay. Same thing. These are same things. I don't care. Okay. What about this one? Capital F's. Well, fundamental theorem. They're actually, this is the fundamental theorem. And that's finding out what that is using the antiderivative of this find fundamental. All right.
That's what we consider the answer.
Okay, here's one of those shaded region questions. You have to be careful. It says between 1 and 2. 1 and 2 is super easy here. I don't have to do anything. What's the geometry tell you that's just one of these blocks? What's the area of one of these blocks? No. What's the area? Anyone at home? Anusha, what's the area? This block. Right there. Pretend calculus didn't exist. You can give me the area of that, can't you? What's area?
Yeah, wouldn't it just be 0.5?
It would be tricky because this is measured to be 1, between 1 and 2, but that's 0.5. So this is 0.5 times 1. So the answer is 0.5. Thank you, Anisha. On next one. By the way, on this quiz, you could be given any one of those 3 areas. That one just happened to be easy, but the other 2, you might have one of them, you might have to use an integral to find. And then you might have to do 2 of them or all 3. But I think it's the same picture. I think everybody gets the same picture and the same equations, but you just have different parts to get. So be careful when you're doing something like that, that you know exactly what it is you're trying to do. In other words, if you see something that looks like a quiz question that you had, don't be convinced that it's the exact same answer. I know people do that to me. Sometimes they give me an answer without showing me any work, but sometimes they're right and sometimes they aren't.
Will these questions be?
More questions?
The question like this, where you
I love these questions.
basically just plug it in.
Well, some of them, they range in difficulty. There's just plug it in. There's change some number. There's don't do anything. The last one we did was just don't do anything. The answer's right there. Then some people will have one where you have to change the numbers.
Yeah. But that would be on the price.
Sometimes they won't come with an equation. I'm not sure that this one does. This is an average distance between hours 4 and 9. So let's remember that. Just copy it down. Copy. Clicking on the distance. There's no formulas here. So what do I have to do? I have to come up with, use integrals. Integral. Between 4 and 9. Of what? We have a function, it's f of x. At least that's easy, dx. Okay, that's the area under the curve. Is that the average value?
Subtract.
I have to divide it by 9 minus 4. So this one wasn't so gimme, but it also isn't that hard. 435.76. How many decimal places? 2 decimal places. Hope it's correct. Oh, got it wrong. Oh. We got it right, but it's marked wrong. Again, do not give up hope because these are automatically graded sometimes, and then I have to go in and
Jane
change.
just gave us partial.
Give you full credit. Oh, did it say give us a fraction?
Yeah. That seems like something.
And yes, there are people in this world who would mark it wrong or take off some points. I'm not generally that person at all. Follow instructions. I don't know. Am I a bad person? Sorry, I'm remembering a cartoon because I'm vegan. Remember a cartoon of these witches and they're sitting at the dinner at the table and they're witches and they're saying, I'm vegan. It's the witches. And they said, but of course I still eat children. This makes me laugh because that is not vegan anyway. Sorry. I don't need to be. All right, we did 9, right? Wasn't that quiz 9?
Yeah.
Okay, we have one more quiz. And we should feel good about it. Quiz 10. I went over quiz 10, didn't I? I think I did last time. I didn't remember. Okay, if u is sine of x, what's the differential? Oh, look, this answer is correct. When I went over it the other day, it wasn't right. Is it integration by substitution? Is it parentheses, exponents, and denominators? Cosine of x dx, u of a, and u of b? None of these. Okay, we'll give u is the sign of the differential is just the du equals, take the derivative of sine, you get cosine of x dx. Boom, that's it. U would be the answer that is used for, that's the letter we use for substitution. They call it U substitution. Parentheses, exponents, and denominators, those are the things that we usually use. Those are good candidates for substitution. Integration by substitution undoes the chain rule. The chain rule is the derivative. Integration undoes the derivative, but integration by substitution undoes the chain. U of A and U of B, those are the endpoints when you have a definite, when you're doing a definite integral and you're using U substitution. The endpoints are U of A and U of B. You did that. We talked, maybe that was an important thing we talked about. You'll see. I'm sure it's on this quiz. Okay, say this. Who do I have? Suhave.
Do you want me to say it or answer it?
I want you to hear you say it.
Okay. U equals a to the x. Du equals a to the x natural log of a of dx.
That last of doesn't belong here, but everything was great.
Okay.
Just say natural log of a dx. Very nice. Do you guys find these things hard? Just out of curiosity, Suhave, was that hard or just you were nervous because you were talking in front of everybody?
No, I think these are probably like the easier ones, but I think it was just nervy.
I think it's good to say stuff, even on a test. Man, I met this kid the other day at the gym, and he came up to me and talked to me, and he said, my mom says I need to practice talking to people. I'm like, really? It's like 25 years old. I feel bad. But anyway, say stuff. Get used to saying it. It'll sound, the more you hear yourself say this stuff, the easier it will be for you to say it. The more confident you'll feel about it, the less you'll be afraid of it. Okay, take a picture. Although I can always go back. Back substitution. Substitution on a definite integral. Finding the differential in a substitution. Only substitution. Integration by substitution. All right, here we go. We have to do, I don't know, which one were we supposed to do? 32. Okay. Okay, there's only one. All right, what's happening here? Okay, the integral is not being solved, but a substitution is being done. So this is just U substitution, no integration. They replaced all the X's into U's, they replaced them all with U's, but they didn't do any integration. So this was just only the substitution part in integration, not the integration. Integration by substitution would be the whole thing. This was just the substitution part. Okay, good. How about this one? Again, no integrals being done. But this is integration on a definite interval. This is what you missed. This is integration on a definite integral. See, there's -5 to 5. And so now they're doing the substitution. They're saying U equals this, du equals that. And now they're doing it. They're replacing it. That's the substitution part. Okay, but it's on a definite integral. So they're replacing everything, including look at the endpoints. So the endpoints, which were 5 and -5, are now U of 5 and U of -5. And U is just what's given here. So you just put 5 in there. 5 squared is 25 plus 4 is 29. 29 to 29. So this is a substitution on a definite interval. Okay? This already has the substitution on a definite interval. What's actually happening here? I think this is supposed to be the same thing, but it's just honestly the substitution's already been done here. And then they just plug in the values of substitution. I don't think that's integration by substitution. I think it's substitution on, I think it's this one, substitution on definite interval. That's what I think it's supposed to be. But this part here should have been there. Okay. This is also substitution on a, there's a U, there's the integral, and now all this is the substitution with the definite interval. You see how the U, it's U of the endpoints instead of the endpoints. Okay. This is just finding the differential. There's no, that all they did was say U is this and du is that. Isn't that one of our choices? Just find the differential. Finding the differential in substitution. That's all that is. 17. Finding the differential. 20. Finding the differential. 23. Finding this. This is finding the substitution, finding the differential. And substitution. I think these are all the same. Finding the differential. I don't know what this one though. This one's actually done. Okay, this is the whole thing from beginning to end. That is U substitution. Okay, so they went from here to there to there to there, and then they actually, maybe this is just the back part. Hold on. What are we doing here? No, I think it isn't. This is all the substitution, integration. Here, all they're doing, this is the last step. They're replacing the U back with this, with cosine of X. So this is just the back substitution. That's when it's back substitution, boom. Okay. That's not our answer though. 29. This is the integration. This is integration and back substitution. So I would say that's integration by substitution. That's the whole thing. Comes to the answer. It's the whole thing. But it looks like it's. This is Calc 2. What Calc 2 is going to be, man. So here's the integral. Here's the U. There's the du, and now they're doing the substitution and finding the answer. Okay, I don't know what that is, 32. Only this, it's not only the substitution, it's not finding the differential. It's not, that's substitution on a definite interval. Nope, it's definitely integration by substitution, I'm guessing. Because it comes to the answer, the whole thing. They're giving you the u and the du, but you're still doing integration by substitution, and the whole thing's being done. All right, here, same thing, whole thing's being done. Okay. Fun. You need to watch that video.
That was terrible.
Okay, so here we go. Fill in the blanks. Okay, so this is one of those questions that you would see on the quiz. Okay, so I'm trying to do this substitution. All right, so I'm just going to write it down. The integral from 3 pi over 2 to 2 pi of minus 3 sine of x f of cosine x dx. It can't do it because there's no function. So let's make up a function. F of x equals, I don't care. Give me a function, any function. Pick a function, any function.
X squared.
There's the answer 1. Now, if we play our cards right, we can do a substitution on this and it'll stay 1. So what would be a good substitution? They're telling you that they want it to look like f of u. So cosine must be u. So u of x equals cosine x. Okay, du equals minus sine of x dx. Okay, so now let's take this whole thing and do the substitution. Oops. And put the stuff in. So this is u, right? The derivative of cosine is minus sine. Okay, so the only thing I have is this 3. That 3 is not used anywhere. So I'm going to take that 3 and I'm going to put it out front like this. Okay? And now minus sine of x dx is all going to be, let me just say that, and that is just going to give me du. Okay, and you see the answers are terribly different because what did I have to do that I didn't do yet? I have to make the endpoints u of that and u of that. When I do that, let's see if it'll work. I don't know, I never tried it this way. It's not working. So what is u? Here's u of x. So what's u of 2 pi? That's 1. What's u of 3 pi over 2? That's 0. So this integral here must be between 0 and 1. And now the answer is the same. See? We got 1 up here. Okay, so that integral that they gave us was 1, and now it's still equal to 1. Okay? If you do it right, doesn't matter any function, you could have said plus 7. Oops, sorry. So you get a different answer, but they're the same different answer for both of them. Okay, so now answer this question. Now that I have it in this form, what is a equal to? Look at our line 55. What is a equal to? That's the number in front of the integral. What is the number in front of the integral? 3. Generally speaking, it will be that number or negative that number. Only if the problem is that negative went away with the sum, because the derivative of this, because the differential had a negative in it. But if the differential didn't have a negative in it, then that would have been negative 3. Okay, b is the lower limit. What's the lower limit? And the upper limit is 1. Okay, this question specifically dwells on the part that these limits of integration have to do with x equals. Remember, this is the area under this of the curve. That's this between x equals 3 pi over 2 and 2 pi. This whole thing is the integral when u goes from b to c. So this is a whole different function. It's so you have to have different limits integration. Okay, I like this one a lot. The number of graduates one. This is the number of, if you look at it, it says the number of calculus graduates each month. It's January of 2000, so 0 must be January of 2000. They did a regression, there's the regression, there's the limits of integration, there's an antiderivative, there's a summation, this is all stuff that comes off you. Now there's a lot of stuff. You have to figure out what they want. Use the regression and the approximate area. So they don't want the definite area. They don't want the fundamental theorem stuff. They want the approximate area. 12 times a year. So that for 10 years would be 10 times 12. So I have to go to n and I have to change that to 10 times 12. Just 120. And then after 2010, ooh, this is after 2000. So what do I have to do to make it 2010? Oh, that's January of 2010. Okay. And then, oh, they want it for how many years? 10 years. So 10 to 20. That's right. 10 to 20 is 10 years after 2020. So the answer is 5815. The exact answer would be 5847. They want 5816. They want students as whole people. All correct. 5816 was correct. Correct. So do these as many times as you want. Have fun. Be careful though, that last one had a typo in it. The typo was it said 10 times, it said 20 times 12, but it was only 10 years, so it would be 10 times 12. If you want months every month, and there's 12 months in a year for 10 years, it's 120, not 240.
Yeah.
So it said the wrong thing. Yes. So, so stretching. You know what I used to do? I hate to reminisce about my teaching days. When students did that to me, I would do this to them. He's not looking. I would just point at them. And they'd be like, what? Point and stare. And they'd be like, what? Said, oh, nothing. I was just stretching my finger. Those are the good old days. What? This one?
Yeah.
Yeah, so the number, so this is substitution one. That you have to see that f has the cosine in the inside, so that u is going to be cosine.
So du is sine negative
Minus the sine of x dx. The 3 just goes right out. Okay, so that a is going to be the 3.
Would you even have to plug in the du if you're just trying to find a, b, and c?
Well, b and c are just going to, once you have the u, you know how to get b and c. You just evaluate these things. The 3 pi over 2 and the 2 pi at cosine. Okay. But that 3 is probably coming out. It's
So
just whether you're just, you know, you as I said, the one way to cheat on this problem is you can't, there's no function here, but you can just make up any function you want. And all you're looking for is to see that it's the same. If it's the same, you're good. I got to tell you what I do sometimes in life when I don't remember something mathematical. Sometimes I just let the calculator or computer tell me what it is that I'm missing. You know, I don't remember, does this formula work or not? Let's try it on a subset, like a small number, and say, oh yeah, it does work. Like that one formula that had 99 problems, so you could just have done that to 3, and you could just added up the first 3 numbers of n squared, 3, 1, 4, and 9, and so you better get 14. So you plug that into the formula, and if it works, you're good. If it doesn't work, you're not good. All right, anything else? those were the quizzes. 5:12, like a 15 minutes. Let's talk about what I'm going to give you tonight.
It's a test, right?
It was the test. And I wouldn't worry about it until you're ready to start. You have the project to do between now and Saturday. Today's Thursday, Friday, Saturday. You basically have 2 days to finish it. If you finish it and post it early, that's great. There's a spot for you to post it. Put it up. Have fun. But as soon as Saturday's done, I don't want you working on that anymore. You're working on getting ready for the test. Actually, people's asked me, when should I post my video? I don't care when you post your video. Just make sure it's up by next class. Because it's our last class and I would like to see some of them. Okay? Actually, I would like you to see some of them. I can see them anytime. I can see them on the toilet. You will probably not look at them unless I make you sit here and look at them. But they're worth looking at. Your classmates, what your classmates do is a good thing. All right, so let's get back to this. What am I looking for? I'm looking for the test. I said I put the test up, but it's not up. Because I don't know how to put it up yet.
And it graded.
It is not to be graded. I will not look at it. It is not to be graded. I think when I put it up, let me go into mod 11. Let me do it right in front of you. What the hell? I just don't know. You're going to be my guinea pigs on this. So in mod 11, so lessons, mod 11. I'm going to put it here, right? Does it say integral? Where does it say the integral stuff is? It doesn't, but we'll put it in. It says it's in 10.
Oh yeah, what are the exam questions here?
Never. You do them. Because you do them to see if I made a mistake. That's why you do them, and that's why I want them done. Now, if you wait until after the exam, they're worthless. You're there for you. You should correct your mistakes because the mistake that you're most likely going to make, like once I mess up a person's name, Melanie. Is your name Melanie?
But like the thing is,
In my mind, your name is one of the hardest names for me to remember because I want to call you the one with the D. Because I know a person whose name is that with a D. And my process is don't call her the name of the person I know whose name has a D in it. And that's how I remember your name. It's horrible. But because I made a mistake once, I will make that mistake over and over again. And that's what I have to study. Whereas Devon, I've never made a mistake with his name as far as I know. Devon's like, I did the. What is it?
It's like Davion.
Well, then you never corrected me.
Yeah.
You're
For like 2 semesters. Well,
Like,
yeah, it was
the
close.
thing is,
Devon.
Davion. But it was close enough, so I was just like most.
You didn't correct me. I will never.
Okay.
I'm just going to tell you, I'm never going to get it right because now I've studied that every time, and I got one class to study it. It ain't going to happen.
That's all right, man.
Sounds like Avion. Yes, like the drink.
Yeah.
Yeah, I still won't remember it. Sorry.
It's okay.
I'm sure.
I guess it wasn't a big deal.
And you've had me for 2 semesters.
Yeah.
That's
Never said.
okay. Study the mistakes you made. Do them. If you find any mistakes, let me know. I'll give you more points.
it's like the thing is like if I'm doing like the test corrections and stuff like, but the thing is I got points on the test because I didn't say it before I typed.
Yeah, I hate you for that. Which would you rather, points or me hating you? No, don't do that again. And then ask me, don't do it on, here, don't do it on the vinyl. I know, don't write it, then open up a Desmos sheet and type it in. No, don't do that, because those spoken ones, you have to answer quickly.
Oh, just say it.
The problem is I'm waiting for you. This is why I don't hate you for this. I'm just sitting there, I'm waiting for you. Maybe I am. I couldn't find any because I'm not teaching much longer, but I'm sitting there waiting for you to say an answer and your typing isn't fast enough. No, but, and that's why you're giving me time to write a note to you and take off points, which is more work for me. You should say it fast and then type it, because if you say it, I'm done with you. I'm waiting. So if you say, if I say, what is calculus, and say, calculus is that, I hate that I type when I type in class. I hate myself for this. You see me typing stuff and I'm looking down at the keyboard, I'm like, I hate myself. Why didn't I do this before class? I mean, I like being, I like looking at stuff. I like being all flexible. But if I were like normal professors, I'd have it all typed out. I wouldn't have any, if it's all typed out, am I typing isn't that fast?
We say it correctly, but.
Just say it and you type it, I don't care. Once you've said it, I've moved on. I'm just waiting for you to say it.
Like, put it down,
Don't even have to type it in.
don't even have to.
But here's why I recommend you type it in, because that's the only way you have proof that of what you said. And because you don't get the videos, but you see what you thought you said. I'm not, if you challenge it after the fact, I will pull up the video and say, yeah, I took it off because you said it wrong in the video. The video is what counts. But if you will notice sometimes that you get points for something that's wrong because I listened to what you said. You said it right, but you wrote it wrong.
Say it wrong, right?
If you say it wrong, you lose points. If you say it right, you get points. It doesn't matter what you write. It says all over the instructions. I don't care what you write. That's for you. It's for you to learn from, or you to have as your backup of your documentation. But I want to hear it. But I'm just saying, when you're typing, you're killing me. I'm aging. Every second that you spend typing is another second I'm aging, waiting for you to get the answer out and say it out of your mouth. And literally, I'm screaming at the computer, say it, say it. You think you're the other kids. I'm just like, I'm waiting for you to say it out loud. So don't type it, just say it. And then take a break. You're going to get a cigarette. Once you've said it, if you got up and walk, I shouldn't say this because it's probably not true. Go ahead. But if you get up and have a cigarette, eat and pee or whatever, I've already graded that problem. So Desmos will have, not Desmos, Honorlock will have a fit that you got up. I'll be like, what? And the timer's still ticking and I'll get flags and warnings and stuff. And I will look at that. But if you've already answered the problem, I don't care. And I don't care how much time you spend between problems if you've already said it correctly. But if you haven't said anything, every minute you spend sitting there not saying anything, I get really mad because people do that. They just sit there. I don't know what they're doing, scratching their butt or something, but they're not moving on. And I'm sitting there watching them.
I think about it. Like, I'll be saying it wrong sometimes. I'm like, oh, wait, I said that wrong.
Just say it. Here's the thing. I don't take off for you just saying it and then saying, oh, no, I said that wrong. Wait a sec. And then you fix it. It's okay. Don't take off. I didn't take off any points for that. Because I appreciate that you're trying to get me out of there fast.
Yeah.
So you're saying what you think is the right answer, and then you change it. And actually, I do look at the answer on the screen. If the answers don't match,
Yeah.
I will think that I will wait another second or two to hear if you fixed it. You have to fix it right away. If you wait 10 minutes to fix it, I'm not waiting that long. I've moved along.
For our midterm, we're still getting the curve for that too.
Midterm? What?
Is there a curve for the midterm?
Yeah, you get 20 points, but you better keep reminding me. Sarah's going to remind me for sure.
So I'll try out. When you said for the midterm, I'm like, wait, am I wrong? I could have swore it's
What is 20 points worth to 2% of your grade?
not 100%. Heard what I got, 20% will do a lot
20 points is 2% added to your grade,
still.
overall grade. So that's good.
Oh, like overall.
Oh, yeah,
The class.
overall grade. 20 points. There's 1,000 points in the course.
Yeah.
So 20 points is 2%.
Yeah.
Of 1,000. I believe. Okay, so let's take a look at the test that you want to. It's called the integrals test. There's a practice integrals test too, but I think I'm just going to give you the integrals test. I honestly don't know the difference between the two. We'll take a look. Huge amounts of instructions because it was a test. Okay. Yeah, I don't know what that is. I don't care. No, you don't need to see the instructions. There's no honor lock. I'm not enabling it. Make available to students. Yes. Multiple attempts. Do you want multiple attempts or no?
Yeah.
Sure. But it doesn't. I don't want to grade it. So that's the problem. So I'm just not gonna grade them, so they're gonna sit there ungraded, so you know. Force your completion, you have an hour to do it. When is it due? It's due on Tuesday, the 10th at 3 o'clock. 3:30. Not allowed. It is not going to be included in your calculations. Hide results for this test completely from instructor and itself. Hiding the results. Do you see that? Hiding the results. So even from the instructor, I won't even see this. And then after you submit it, what do you want? You want to see everything after you submit it? Correct answers. You could see it all after you submit it. There you go. So you'll submit it and it'll show you everything.
Wait, how many tries do you have?
It says unlimited, but it's not one at a time. Okay. I don't know. I think it won't show up for me. So you can do it all you want. It ain't showing up for me. And it's not showing up in your grade book because I think that's what I just said. Hide results for this test completely from instructor and the grade center. So I don't even know if you'll get to look at it. I hope you will. I hope it's not just going to say needs grading, but that may be what it says. So you might want to actually write the questions down. Or take a picture of them with your phone. I hate the whole idea of writing something down. So as soon as you know something, let me know. But that integrals test is in, let me just edit it. So it says, hold on. Not for credit. Is that clear enough? All right. Hold on. You want to see what it looks like? It's this many questions. It's 15 questions. There are 15 questions. It's a lot like the derivatives test. It was a nice test. But since I'm giving you a project, I'm not giving you this. And the problem I had with this test was that it was too similar. Like, in other words, if a person got a 0 on this test, they missed a third of the final exam because a third of the final exam came from this test. If they got 100 on this test, then they got 100 on that part of the final. They didn't get 100 on the final. They got 100 on that third of the final. So this test was too close to the final for it to matter anyway. Students were not learning between when they took the integral test. Like if you got a 0 on it, I would hope you do better on the final, but no, nobody was. Like if you got a 20% on this test, you got 20% of the questions on the final. So I'm just telling you, no point in me giving you the same test twice. You're taking this for yourself. And when you see that you don't get it, then get it. Work on it, learn your mistakes because you don't have that much time between now and the final. But I'm going to see how you're going to do on the final soon enough. So I don't need to see it a couple days earlier. So by all means, learn from your mistakes. Is that everything? Are we good? Do you have any questions at home? Thank you all for coming. People who came from home, they've already gone. Jacob's the only one left. What the hell?